Okay, here are your notes for section A5, summer homework. The types of problems you're going to see for this section are asking you to solve the rational equations, where you need to solve for x. We'll also solve for x by factoring something that's again bigger than quadratic, so using probably synthetic division again. And then we're going to solve a radical equation and an absolute value equation as well. So those are the types of problems that you should have for the homework. Alright, so looking at letter A, I'm solving an equation where I've got variables in the denominator like we did for section 4. I need to get the least common denominator, so again, that's factored. The second denominator is factored, but the third one's not. It factors into x plus 2 and x minus 2. So the least common denominator looks like it actually is x plus 2 and x minus 2. So this first term is missing an x plus 2. So I'm going to multiply that first term by x plus 2 over x plus 2 equals the second term, the 3 over x plus 2. It's missing the x minus 2, so I'll multiply by x minus 2 over x minus 2. And then the third term is not missing anything, so I don't have to do anything to it. It's already got the least common denominator. And now, when we were doing section 4 and we were just simplifying, we just left the denominator alone. Since I'm solving, I'm going to get rid of it. I'm going to choose to multiply the entire thing by the least common denominator, which means I'm going to multiply everything by x minus 2 and x plus 2. And what happens is that that's just going to cancel the entire denominator. Imagine if there was 4 in the denominator and you multiply by 4, the 4's would cancel. Same concept. So now I can just solve the numerator. So distribute the 1 to get x plus 2 is equal to, distribute the 3 to get 3x minus 6, and then make sure you catch the negative there to get negative 6x. So that's kind of the difference. When you're simplifying, you need to keep the denominator and you want to leave it factored. When you're solving, you can eventually get rid of it. If you don't get rid of it here, you can get rid of it later. But get the common denominator and then get rid of it. Now just continue to solve. This is not quadratic, so get all the x's to one side. I'm going to leave the left side alone. I'm going to simplify the right side. It looks like it's negative 3x minus 6. I'll go ahead and add 3x over to the left side to give me 4x. I'll subtract 2 to give me negative 8. And I end up with x is equal to negative 2 when I get done dividing. And then one thing you have to remember when you're working with rational equations is that it's possible the answer doesn't work. Not because I did any of my algebra wrong, but remember you can't get 0 in the denominator. So if you go back up here and look, they're called restrictions on the domain. If you set each of these equal to 0, you shouldn't get one of those for an answer. So for example, if I list off the restrictions, x cannot equal 2. If it does, this first fraction is undefined. X cannot equal negative 2. If it does, the second fraction is undefined. And this one says x can't equal 2 or negative 2. So this cannot be an answer. So since it is, that means I have to cross it out. And realistically, my answer is there's no solutions. I can never get this function to actually equal each other. Alright, so looking at letter B, kind of keeping that in mind, same thing. X can't equal 0 if I look at this denominator, and x can't equal negative 1. So if by chance I happen to get one of those answers, I'll again have to cross them out and say no solutions. So it looks like my denominators are basically factored for me already. It's just x, x plus 1, and 1. So the least common denominator is going to be x times x plus 1. So I'll have to multiply that first fraction by x plus 1 over x plus 1. I'll have to multiply that second fraction by x over x. And then don't forget about this 3 over here. Right now there's nothing in its denominator other than a 1. So I need to multiply by x and x plus 1 in both the numerator and the denominator. And now, like I said, now that I have this least common denominator, I'm going to multiply all 3, or however many terms I have, by that least common denominator, and it will cancel the denominators out so that I can focus on the numerator. Go ahead and distribute the 1 to get x plus 1. Make sure you see that that's negative, so distribute to get negative x is equal to, this is 3x times x plus 1, which would be 3x squared plus 3x. I recognize this is quadratic, so I want to set this equal to 0 and solve, so I'm going to move everything to the right side. The x's cancel themselves out. I just have to subtract 1. So I have 3x squared plus 3x minus 1. And I notice that it's quadratic and the first term's not a 1, so if I multiply the front and back, or the earmuff method, I get negative 3. No factors of negative 3 are going to get me positive 3 when added together. So this means quadratic formula. So x is equal to opposite of b, so negative 3, plus or minus the square root of b squared, which would be 9, minus 4 times a, which is 3, times c, which is negative 1, all over 2a. Hopefully you remember the quadratic formula. If you don't, it's something you want to review. Alright, continuing to simplify, I have negative 3 plus or minus the square root. This is going to be 9, double negative here, so plus 12 or 21 over 6. And I'm going to go ahead and split it. I have two terms in the numerator, just one in the denominator, so I can split it and say that this is really negative 3 over 6 plus or minus the square root of 21 over 6. And my last little bit of simplifying, I'll go ahead and simplify that fraction so it's negative 1/2 plus or minus. If I could simplify that radical, I would, but right now only 3 and 7 go into it, and those are both prime, so it actually is simplified. And so this would be my final answer. Remember, two answers. You have negative 1/2 plus this number and negative 1/2 minus this number. Now you might say I need to know what numbers they are so I can check them, but all they have to do is not be 0 or negative 1. And those are definitely not 0 and negative 1, so they will work, assuming that I didn't make any errors. Alright, so that's solving when you have a denominator. Get a common denominator, canceled out. So now let's look when I don't have a denominator and just have a polynomial, or quote-unquote regular equation. Just like we did in some of the other sections, I recognize this is x to the third, and I recognize there's a number in back, so that means I've got to do synthetic division. So I would start by making sure everything's in order. It looks like they are, nothing's missing. And I would start by doing 1, 2, 3, 6. And of course, since this leading coefficient is a 1, I would be basically looking at the factors of the back number. So I'm looking at 1, 2, 3, 6, plus or minus all of those. So there's 8 numbers that I'd have to sit and guess and check. And eventually I'm going to get the right answer. When I guess and check enough, I'm going to find out that negative 2 is the one I'm looking for. So we're going to drop down the 1, multiply to get negative 2, add to get 0, multiply to get 0, add to get 3, multiply to get negative 6, add to get 0, and sure enough, it worked. Now it's asking me to factor and solve. So right now this, I can factor it into x plus 2, or I know that x is equal to negative 2. So I don't really need to factor that part of it. For this one, however, this is going to factor into x squared plus 3. And remember, realistically, this is set equal to 0. So if you wanted to just do the factoring, you would have x plus 2 times x squared plus 3 equals 0. I kind of skipped this factor because I knew that that was going to give me negative 2. And so now setting this equal to 0, if I move the 3 over, it's going to make it negative. Take the square root of both sides, don't forget plus or minus. I get the square root of a negative number, which you remember, that would be no real solutions. If you want to give me plus or minus I square roots of 3, that would be fine also. But if you gave me no solutions, it just depends on the section that you're covering. Sometimes they want you to say no solutions. Sometimes they want the imaginary number. It doesn't matter. I'll show you a trick that sometimes works, sometimes doesn't when you're doing synthetic division. Remember when you were doing the earmuff method, how you always multiplied the front and back together, and then you got a factor that would add together to give you the middle number, and you changed the middle number into 2 terms so that you had 4 terms total, so you could do the factor by grouping? Well, we have 4 terms here. And like I said, sometimes this works and sometimes this doesn't. If I try the factor by grouping, notice the first 2 have x squared in common. That would leave you with x plus 2. Notice the second ones have a 3 in common. That would leave you with x plus 2. As long as those are the same, this little factor by grouping trick would work. And it would factor into x plus 2, and then the 2 things that got factored out, x squared plus 3. And sure enough, that's the same thing we had over here. Like I said, be careful. If this doesn't work, that doesn't mean that you can't factor it. It just means that this trick won't work. You have to do the synthetic division. But you can try that. If it works, great. If it doesn't, do the synthetic division. Either way, make sure you know how to do the synthetic division, because you will need to know how to do that. Alright, this next one, again, it's definitely bigger than quadratic because it's to the 9th power. Remember what I said I normally do. After I see that it's bigger than quadratic, I usually look back there to see if there's a constant. I notice there isn't one. That's good news, because that means they all have x in common. So I can factor out x, which would leave me with x to the 8th minus x to the 4th minus 6. And right now, maybe that doesn't seem like that's helpful, but do you notice that when you have a quadratic, and this exponent is twice as large as this one, it just factors into x minus 3 and x plus 2. As long as this exponent is twice as large as this one, kind of like we have right here, followed by a constant, you can actually factor. This will factor exactly the same as this, other than it's not x minus 3 and x plus 2. It's going to be that term. It's going to be x to the 4th minus 3 and x to the 4th plus 2. Called quadratic form. Anytime that you have three terms, first exponent is twice as large as the second and followed by a constant, you can pretend like it's x squared minus x, or whatever the case may be, minus 6. Factor that, and then just put whatever this exponent is in here. And you can see if you FOIL it out, if you multiply the first together, remember add exponents, it would be it would be x to the 8th. Insides and outsides would give me negative 1x to the 4th, and the last gives me negative 6. And now since they are factored and all multiplied together, I can just set each term equal to 0. So it looks like x equals 0. If I add 3, take the 4th root of both sides, I would get x is equal to plus or minus 4th root of 3. Or sorry, 4th root of 3. Plus or minus, yeah, don't worry about it right now. There's actually 4 answers to this. We don't know how to find all 4 of them. So let's just leave it as the 4th root of 3 right now. You'll learn how to do that next year. And then this one, remember it's an even root. So if you took the 4th root and you end up with a negative number in here, that again is going to be no solutions. So if you have the square root, definitely put the plus or minus. For now, if you have any other root, just put the 3rd root, 4th root, whatever the number is, and stop there. So I'm going to have zeros of x equals 0, x equals the 4th root of 3, and then that's it. Alright, so factoring and solving. On to the next couple. Solving a radical equation, what you want to do is get rid of this radical, and the only way to do it is to square it. Now, I don't want to square right now, because if I square right here, that means I'd have to square a quantity, and I'd have to FOIL, and when I do the insides and outsides, I'm going to end up with a radical again, and that doesn't really help me. So what you need to do is get this radical by itself, so subtract the 3. That would be your first step. So I have x plus 2 is equal to x minus 3. Now when you square both sides, you don't have a quantity on the radical side, so it just undoes the radical, and you have x plus 2. Yeah, you will have to FOIL over here, but at least you don't have a radical in the equation. That's kind of what your goal is to get rid of that radical. Now that that's gone, that's just solving like any other quadratic that you've solved before. Set it equal to 0. So I'm going to subtract x to make that negative 7x, subtract 2 to make that positive 7, and kind of like one of the problems we did on the last side, it's not going to factor, so I have to use the quadratic formula. Now, one other thing that I'll keep in mind when I get to the end, anytime you square both sides, it's possible that you've introduced something they call an extraneous solution. It just basically means that it's possible your answers don't work. And it's not because you did your math incorrectly, it's just that one of the answers may not be true. Or both of them might not be, so you have to actually check your answers for this one. So, we'll worry about that when we get there, but we have to keep that in mind. I'm going to go ahead and use the quadratic formula, so it's going to be opposite of b, so plus 7, plus or minus the square root of 7 squared, minus 4 times a, which is 1, times c, which is 7, all over 2a, which would be 2 in this case. So I have x equals 7 plus or minus the square root of 49. That's eventually going to give me negative 28. So adding those together, I get 21 again, all over 2. All right, now because I have to check my answer, I don't want to leave it as a radical. That's not going to help me out. So I figured out that radical for you already to save us some time. It's going to be 7 plus or minus approximately 4.58 over 2. And so now I'm going to actually figure out the number. 7 plus 4.58 divided by 2 would be approximately 5.79. And then if I say it's 7 minus 4.58 and then divide by 2, that would be approximately 1.21. And now when I go to check my answers, I'm going to go right back to the original equation and see, will it work? So let's start with the first one, 5.79. I've got the square root of 5.79 plus 2, or you could say 7.79 right away, plus 3, and I need to ask myself, is that equal to 5.79? Now I rounded this, so it might be slightly off, but as long as it's close, it will be okay. You can plug that in your calculator and you will find out that sure enough, it does work. It will be approximately 5.79, so it works. So that answer we keep. Now we got to check this one. So I've got the square root of 1.21 plus 2, then plus 3, and then asking myself, is that equal to 1.21? Now without a calculator, I know this isn't going to work because this has to be a positive number. If you take a positive number plus 3, it's definitely going to be bigger than 1.1, so I know that's not going to work. You'd have a calculator, quick throw it in there, you see that it doesn't work. So you eliminate that answer, and that's the only answer you end up with. And if you wanted to give an exact answer, I would be fine with this, but you could go back and write it as a radical. It would be 7 plus the square root of 21 over 2. And there would be the exact answer. So the big thing is, remember to check your answers. Now, it's possible that both of them don't work, which would mean you would say no solutions. Possible that just one works, like this happened. It's possible they both work. You just have to check them. And the same thing is true with this. When you solve an absolute value function, you're going to solve and get multiple answers, and you're going to have to go back and check. Again, it's not because you did something wrong. It's just possible you have a solution that doesn't work. Now, I have an absolute value, kind of like a parenthesis, but I can't just drop that. I can't just distribute the 1. What I'm going to do, and you can do this a couple different ways, is you can take what's inside the absolute value and set it equal to the positive of whatever's on the right side, and then solve. And you can also set it equal to the negative. So now imagine if I distributed negative 1 to that. It would be negative x squared plus 10x. You can do the same concept and do the plus and minus of this, set equal to that. Same concept. Now I have to solve both of these. So they're both quadratic, so I'm going to set both of them equal to 0. So for this one, I would have to subtract x, which would give me x squared minus 11x plus 10. Over here, I am going to actually add everything to the left side. Again, I like everything being positive with the leading coefficient. So I'm going to move the x squared over to the left. I'm going to subtract 10x, which will give me negative 9x, and then I still have that negative 10. Luckily, both of these factor. This one will factor into x minus 10 and x minus 1. So as of now, I have x equals 10 as a possible answer, x equals 1 as a possible answer. On this side, I have x minus 10 times x plus 1. So again, I get x equals 10 as an answer. I don't need to write it twice, but it's there twice. And I have x equals negative 1 as a possible answer. So I've got 3 numbers I need to check. And again, we're going to go back to the original equation, and we're going to plug in positive 10. So plugging in positive 10 would give me the absolute value of 10 minus 10, which of course we know is 0, is equal to 10 squared, which is 100, minus 10 times 10, which is 100, and you're going to end up with 0 equals 0. So sure enough, 10 does work. X equals 10 is one of our answers. Then let's go ahead and try positive 1. So now I plug positive 1 in to my original equation. That's going to give me the absolute value of 1 minus 10, which I know is negative 9, which absolute value would be 9 eventually. Plugging in 1 over here, I'm going to get 1 squared, or 1 minus 10. Now it's the absolute value of negative 9, so I get 9 is equal to negative 9. And of course, that's not true. That does not work. So x equals 1 is actually not a solution. Then we go ahead and plug in negative 1. So I have the absolute value of negative 1 minus 10, which is negative 11, which eventually would be 11. Negative 1 squared would be positive 1. Negative 10 times negative 1 would be positive 10. You end up with positive 11 equals positive 11, and sure enough, that works. So x equals 10 and x equals negative 1 are solutions. X equals 1 is not. Biggest thing you have to remember is, remember when you have a radical equation or when you have an absolute value equation, you have to check your answers. If you can remember that, you'll probably be fine. Other than that, it's just doing algebra. Hopefully that helps out homework for A5.